The cumBg function is for working up laboratory measurements of biogas volume and composition made from batch reactors over particular time intervals. It'll be easier to understand by example. So the first step is to load the package and then load these two example data sets that we'll be working with. So the vol data frame contains volume measurements from an experiment carried out with batch reactors using different substrates, and we have a total of 9 reactors here. The ID column is what gives a unique identifier for each reactor. So for example, 393 milliliters of biogas was produced from day 0 to day 1.98, so about day 2. The comp data frame contains composition data. Our response here is XCH4, which is the mole fraction of methane in biogas, normalized to a content of just methane in CO2. And I'm just showing a few rows here. So this data frame is 99 rows long. So we can immediately see that we don't have a composition value for each volume measurement. And you can tell here that the date of the first measurement for this particular reactor, 2.1, is 7 days into the experiment, whereas there are 5 volume measurements made before then. So what the cumBg function will do is it will use interpolation, or if allowed, extrapolation, to determine biogas content at each point from which we have volume measurements, and then it'll calculate standardized volumes of biogas and methane for each interval, and then sum those to calculate cumulative production. So the output is a data frame. We're going to save the output in an object named cbg. The first argument is the volume data frame. The temperature at which biogas volume was measured. The composition data frame. The name of the time column within those two data frames. And then, because we're going to need to do extrapolation in order to determine methane content, biogas composition for these early times, for all 9 of these reactors, I think, I'll set extrap to true, which is not the default. Let's look at more of this. We'll take the first 20 rows. So now we have interpolated down here, or extrapolated, biogas content, standardized volumes for each interval, the V columns, cumulative volumes, CV columns, and then rates, the RV columns, the last 2 columns. So it may be easier to understand these data if they're plotted. So I'm going to plot cumulative production using the ggplot function, which is handy for plotting data like these. So we'll say ggplot Okay, so here is cumulative production for these 9 reactors, cumulative methane production for these 9 reactors. The cumBg function is quite flexible. It can be used for volume measurements, as I just showed you, or for mass measurements, applying a gravimetric method. It corrects for temperature and pressure, standardizes to a default of 0 degrees Celsius, 1 atmospheric pressure, but those default conditions can easily be changed. There are 2 different options for calculating production, as well as different options for interpolation. And you can see all the arguments with the args function, or take a look at the help file for these arguments, as well as a description of what they mean and how to use them. But I'm going to talk about a couple that are probably commonly used. So we don't have a time 0 point in the output here because there wasn't a time 0 point in the original vol data frame, but we can add one. Show t0 is the name of the argument, and I'll set it to true. And now let's take a look. So now we have time 0 points for all of these individual reactors. In these calls, I set extract to true, but the default behavior is false. Let's take a look at that. First, you'll notice these warnings, and let's look at the first 20 rows as well. So in some cases, biogas composition wasn't determined because it would have required extrapolation. Where interpolation was possible, it was determined. And where there are no composition data, there are no methane data as well. It's actually possible to use the function with no composition data at all. Call this cumBg3. And now let's take a look. So all the columns for methane are just omitted from the output. These examples were relatively easy because the names of the important columns in our input data frames matched the default values for those names in the cumBg function. Let's look at an example where that's not the case. So here are some similar volume and composition measurements from a different experiment, and the data frames are organized differently. So the names are different in this case. Say cumBg4, cumBg. Now we're working with vol 2. I'm also going to assume a temperature of 20, but that really should match the temperature at which volume was measured. Say count is count2. id.name is now bottle instead of id. Time.name is days here. Dat.name, mes.vol, comp.name, ch4.conc. And I'll also say extract is true. You can see here first volume measurement after 1 week, but we have several measurements made before that. So we'll say extract equals true. We already have a time 0 measurement in the vol2 data frame, so we don't need to say to change the default value of show t0. It'll automatically show it. And anyway, we can only add it when we're working with numeric data for time. Another option with the cumBg function is POSIX data, so date, time, objects, and in that case it can't automatically be added. Okay, let's take a look. Alright, so again, V for the volumes and intervals, CV for cumulative volumes. And let's plot these data. I'm going to use the earlier call. Now the reactor ID is called bottle, cumBg4, and I think everything else is the same. Okay, so different responses in this experiment and many more reactors. The cumBg function, as I mentioned, is quite flexible. You can find information on the default values for arguments and how to use different arguments, how to use the function in different ways by looking at the help file. And in particular, one example that I'll demonstrate in a later video is how to work with this function using mass data. So that is applying a gravimetric method.